Now we're going to talk about perimeter of similar figures. So let's look at this first question. We're given that DEF is the image of triangle ABC after a dilation. So DEF is my image. And the first thing it asks me to do is to find the scale factor. So to find the scale factor, I'm going to take a side of my image and I'm going to put it over a corresponding side in my pre-image. Because this is already labeled DEF and ABC, I know which sides correspond. And it just so happens that DE and then over to F, AB, and down to C, that they're oriented the same way, which is really helpful to me. But I'm going to take a side of my image, which again I highlighted in yellow. I'm going to use the squiggly side, the 18, and I'm going to compare that to 30, which is the squiggly side in my other shape, my other triangle. Now, because this is scale factor, I do want to reduce this fraction, put it in simplest form. Both of these are divisible by 6. So my scale factor in simplest form is 3 to 5. Now you're going to ask yourself, does that make sense? The answer is yes, because this is less than 1 and my shape got smaller. My image is smaller than my pre-image. Now I want us to look at the ratios of the perimeters. But in order to find the ratio of the perimeters, I have to find the perimeters themselves. So let's find the perimeter of DEF. To find the perimeter, I would add up all the sides. So I'm going to take 18, 21, and 30 and add them together. When I do this, I get 69 in my calculator. If I need to find the perimeter of ABC, I would add up those sides, and I get 115. So the ratio of the perimeters is 69 to 115. Now, I don't know about you, but I don't really know the factors of 69 and 115 very well. So you could divide this in steps to get this into a reduced form, or you could use your calculator to help you. If you divide this in your calculator, you would get the decimal 0.6, and then if you go to math, and then hit enter, it will change it to a fraction for you, and the fraction would be 3/5. Now, looking at the scale factor and the ratio of the perimeters, what can we say? Well, here's the scale factor. Here's the ratio of the perimeters. What do you notice about them? They're the same. So the scale factor and the ratio of the perimeters of similar figures are the same ratio. That's going to help us a lot when we have questions with missing information. So let's check out a few. So here I have triangle dawn, and triangle dawn is the image of triangle key after a dilation of 1/3. If the perimeter of triangle key is 18, what is the perimeter of triangle dawn? So let's look back at this question and highlight some important information. First off, triangle dawn is the image, super important. Then I know that it's a dilation of 1/3. If the dilation factor is 1/3, that's the same as the scale factor. Now, it tells me the perimeter of Key is 18, and it wants to know the perimeter of Don. So let's think back to scale factor when we talk about dilation. And scale factor refers to the ratio of a side of an image over the side of a pre-image. So we're going to write the scale factor as 1/3. We already knew that. But now in our second ratio, we're going to take triangle Key being 18, and we're going to somehow fit it into this formula. So is Key my image, or is that my pre-image? It's my pre-image because Don was my image. So because that's my pre-image, it goes on the bottom of the second ratio. And I can put X on top because I'm looking for the perimeter of Don. Now I can cross multiply here. 3 times X is equal to 18. Get X by itself by dividing by 3. And I get X is equal to 6. Let's try another one. Triangle Jan is the image of triangle Feb after a dilation of 2. That's my scale factor. If Jan, the perimeter of Jan is equal to 40, what is the perimeter of triangle Feb? So again, scale factor refers to the image over the pre-image. If the scale factor is 2, I would write that as a ratio of 2 to 1. Now remember, in my ratio, my image needs to be on top. I know that Jan is 40. I was told earlier in the question that Jan was my image. So that means that the 40 needs to go on top in the second ratio. And my X goes on the bottom because I don't know the perimeter of my pre-image. Let's cross multiply. 2x is equal to 40 times 1, which is 40. Divide by 2. X is equal to 20. Now I have another question that we're going to have to do that's going to be a little bit more involved. Let's try it. If the perimeter of DBC is 180, what is the perimeter of triangle DEF? Oof. All right. So in order to do this question, I would either A, need to have all the sides of DBC or DEF, right? Or B, I need to find the scale factor. And then I can use that to find the perimeter. So let's first determine the scale factor. In triangle DBC, there is only one side labeled, and it's labeled 80. Oh, sorry, that was supposed to be a highlighter. Let's try that again. In the other triangle, I have 2 different sides labeled. Which goes along with triangle, or with the 80? Is it the 20 or the 15? Well, when we talked about triangles before, we said that across from any angle, that the angles and the sides are related, right, in terms of side lengths. So across from the single slash is the 80, which means that in my other triangle, across from the single slash is going to be the corresponding side. So the 80 and the 20 are the sides that go together. Now, do I know if it really got smaller or bigger? Not necessarily. I don't know which one is the image and which is the pre-image. But as long as I keep it consistent, it doesn't really matter. So I'm going to name this one triangle 1 and we'll do triangle 2. So I'm going to put my 80 on top and I'm going to put my 20 on the bottom, which would mean that my scale factor is 4:1. Now that I have the scale factor, I can set up a ratio, proportion, comparing my scale factor to the perimeters, because the ratio of the scale factor is the same as the ratio of the perimeters. The perimeter of triangle 1 is 180, so I'm going to put that on top because we kept triangle 1 on top in the first ratio. And I'm going to put an X on the bottom. And now I'm going to use my cross multiplication. 4x is equal to 180. If I divide both sides by 4, I get that x is equal to 45. Now, it might be worth it to go back and look at this question and see if it makes sense. And in this sense, it does, because the bigger triangle should have a bigger perimeter. My smaller triangle should have the smaller perimeter. Well, that concludes today's lesson on determining perimeter with similar figures and the relationship between perimeter with similar